Alright, so here's a similar video to the last one. This is about negative exponents again, but this time solving a more complex equation. We're going to break this one down in a couple of different ways. The first way that I would like to break it down is, since this is all multiplication, we can separate the fractions out. Oops. So this is how it would look when we separate it out. And because it's multiplication, we can do that and it equals the same exact thing. And doing this can help us see the problem in a different way. Another way to break it up is you can say that you can break it up by top and bottom. You can break it up any number of ways. This, I feel, is the best way to do it. It's the most understandable. All right, so the best way to look at it is this first fraction can be broken down. We're going to say that's 1/3. And that comes from dividing both by 7. 7 goes into both of those. We're just reducing that, so that's pretty simple. That's just reduction. Now these next ones are going to use a couple of our exponent rules. If you notice, they have the same base. So u equals u and r equals r, and that's why I broke it up that way. Now if you remember our rule for division, if we have a to the x over a to the y, it equals a to the x minus y. Okay, now that probably doesn't mean anything, but if we take and we multiply it by r to the 6, so r x 6 minus 8, so plus 8 times u minus 10 minus 8. Now, so far, let's just deal with this. We'll deal with the u to multiply. We'll deal with the u in a second. Right now, we'll just deal with the 1/3 r. So I know for sure 3 is on the bottom. R is 6 plus 8. So 1 times, that's 1, right? It's 1. 1 times r over 14, so 3r 14. And then this right here, this u is going to end up being u to the negative 18. Which means that it becomes 1 over u to the 18. Which means u to the 18 goes on bottom. So that is our answer. R14 over 3u18. R to the 14 over 3u to the 18. So by looking at it this way, we help to break down the problem into a simpler way. Just looking for what rules we can use. In this one, we had to use our division rule or quotient rule. Right here. We used that for these first two. But then for this one right here, we had to use the negative exponent rule. So a couple of these rules can be combined. And you can use them to solve various equations. We put them together in different ways. This one, it was easier to change the way we looked at the problem. And by changing the way that we looked at the problem, we were able to see which rules to use. It only worked because it was all multiplication in between, so we were able to tear it apart like that. But by so doing, we were able to look at it a different way and decide what to do with it. This method works for anything that you choose to do regarding exponents when they're multiplied. Pull it apart however you want, group like terms. Make sure that you put multiplication symbols in between to show that you're still multiplying. Then use your rules. Again, this is probably, right here, the most important rule for this one, because it helps you to get down to the point where you can break it down. And then the negative exponent is important for the u to know that it goes on bottom. And if you look at the other video in conjunction with this video, it'll make more sense why that goes on bottom. But this right here, this division problem is important because it's what allowed us to combine the 6 and the 8 for the r and the 10 and the 18 for the u. And that's important because a negative number minus a negative number is a negative number. That's where that came from. And a positive minus a negative, just positive. So it's plus. That's where that plus came from. When you have two negatives, they cancel out and make a positive. So that's something important to remember. And then the positive ends up on top, negative ends up on bottom, because that's where the positive was. If the positive was on bottom, it would end up on bottom, but it wasn't. And so by following our rule, we ended up with the most simplified version. And this is called simplification. We didn't solve for anything, we just simplified. Because this is completely and 100% equal to this. So this and this are completely 100% equal. They always and forever will be. We just use some math and some rules about exponents to solve for those things. Alright, I hope this video was helpful and it was just this problem.